Okay, now that we have taken a look at do loops, while loops, and for loops, I'd like to take this video here and demonstrate various ways that we can manipulate a loop's operation. Okay? What I mean by that is we have the ability to somewhat override a loop. You saw a little bit of that in the last video where we used the break keyword to actually break out of a loop in the middle of it running through its execution. We also have a few other keywords that we can use as well. So we're going to be taking a look at manipulating loops, and here are the keywords we have at our disposal. We can break, we can continue, we can go to, and we can return. All right, break allows us to do just that. We end a loop immediately. So we end loop immediately. Continue. This allows us to skip the rest of that iteration within the loop and start the next iteration of the loop. Go to allows us to, well, just jump right out of the loop and go to a predefined area in code. And finally, return allows us to simply return from the method in which the loop resides, which yanks us out of the loop and out of the method. It sends us back to the caller of the method to begin with. So that, of course, is going to have us finish executing the loop by abruptly ending. All right, so with that being the four things I want to cover, let's go ahead and give some simple examples. Let's start out with taking a look at break. Even though we covered it in the last video, let's officially cover it now. So how about we do something like int I equals a 1. And I don't know, let's pick on a while loop. That's nice and easy. While, a little bit less writing for me, maybe. While I is less than 5, open curly brace. If I is equal to 3, so an equality check, let's break. And you'll notice it's only a single line that's being executed if the value is evaluated to true right here, or the expression is evaluated to true. So I'm not using the opening and closing curly braces just to save space on my whiteboard, but Logan, you will. Next thing we're going to do is the loop itself. So if it's false, we're of course just going to say write out. That is a big I. Right? And we'll just give it one of those I equals plus I. And that'll be it. And then, of course, I'll have you write out finish. Okay, let's trace it real quick. So it goes down. Hopefully everybody sees what's happening. Over on the stack, we have the local variable I, and we have our console. First thing when coming in, right here, I gets initialized to a value of 1, so 1 is placed in here. We come down to the while, and remember the way the while works. The first thing that's going to happen is our expression is evaluated to find out if we're even going to go into the loop. So is 1 less than 5? That's true. So we jump down into the loop and we run into an if statement. Is I equal to 3? The answer is no. So we skip over, excuse me, and we write out I equals, and what is currently an I? A 1. Okay, so here we are. We are at the end, which means we then come back up, and we take a peek. Now, let's think about this for a second. With our current logic, what's going to happen? We're going to, again, check I, is it less than 5? Well, did I ever change? No, it's still a 1. So what I've just done here in trying to demonstrate the break is I created a nice little problem, didn't I?
Right, you've got an infinite loop going because you've created I as an index variable, but nowhere throughout this example has I been incremented. So that means, well, you could go right there, throw that in.
There you go. We'll fix it right here. But here's the neat thing. Since, of course, I'm just kind of drawing this out freestyle right now, you know, not thinking or just talking quickly and writing stuff out, it's very easy to introduce a syntax error in your code or a logic error. In this case, we had a logical error by, well, we didn't increment I, so we were caught in an infinite loop where I was always going to be a 1. So check it out. Now I've added plus plus in here. My operation stays exactly the same what we just saw a second ago, except for when this right line finishes, I now gets incremented to a 2. Very good. So now, is 2 less than 5? Answer is true. Another thing I'd like to throw out there, Logan, this was also a great demonstration of it's like manual debugging in a way, or debugging by hand.
Just the value of doing a trace through some example code.
For sure.
That has identified a problem before we even wrote the code.
That's right. Okay, so is 2 less than 5? The answer is true. So we come down here to the if line, and on the if statement, is 2 equal to 3? The answer is no, so we're going to write out I equals 2, okay? And then we increment, so we post increment I by 1, so 2 becomes a 3. And then once again, we come back up here and we evaluate our expression. Is 3 less than 5? The answer is true. We fall down into the loop. We hit the if statement. If I, which is 3, is equal to 3, so if 3 equals 3, it does. So now we fall into the true portion of the if statement, which says break. That means we just forget everything about the loop and we jump outside where we're now going to write out finished. All right, Logan, so if we create this real quick, we should see the exact same thing. I equals 1, I equals 2, finished. Okay, so we didn't go through. The loop was set up in such a way where we were going to go 1, 2, 3, 4, and we won't do 5 because, of course, 5 would not be less than 5. So we should have seen I equals 1 through 4, but we only saw I equals 1 through 2 because we broke ourselves out of the loop. Let's go ahead and jump over into Visual Studio.
Okay.
And we'll close out. That's our old stuff.
So I'll simply begin a new project and discard this one.
Okay.
Or we can come up with our new console application, and let's code out this example. Let's begin with declaring I and initializing it to 1. Then let's start a while loop, and the condition for the while loop is I less than 5. So we'll put that in, and then we'll block in the while loop. Now inside of here, the first thing we want to do is a check to see if I is equal to 3. And if I is indeed equal to 3, then we want to break out of the whole for loop. You can even see the break is actually lining up with the while by the highlighting. So we know we want to do a check for 3, and if 3 is in case the value will break. Otherwise, we want to write out the value of I. So we'll do console.writeLine, where we will say I equals plus I. All right.
And go ahead and throw the break inside the curly braces just to stay consistent.
I got you. You were just doing that before for space reasons. Yeah.
There we go. It's a little bit easier to see. Now let's go and do a console write line, finished, and read line.
Console write line for finished, and a console read line, and build. Everything is happy, so we should be able to run.
Okay. And what's the problem here?
The exact same. So I've just proved your sample. I was looking at your first version.
But you remember I said it would just be 1 forever, and that's awesome. There you go. It's 1 forever. So let's just put the plus in.
So this is what you had done to fix it. Simply increment I as we printed out, and that yields the result 1, 2, and finished.
So 1, 2, and finished. If we jump back over here to the whiteboard, 1, 2, finished. Outstanding. Okay, so that is taking a look at break. It can definitely be handy. Now what I'd like to do is take a look at continue. So let's go ahead and put something else together. How about we start out with int, let's change things up. Int I equals 0 while I is less than 5. So, very simple stuff I'm doing, but this is for my beginners. Follow me through. Let's start out by first incrementing I. Just throw an extra code in. And then let's do a check. If I is equal to 3 again, I want to continue. And then if it's not, I mean, we're just going to continue on. If that wasn't true, we're going to do a write line, so we'll simply write out I equals plus I, and then end, and then finished. All right, so all sorts of extra stuff going on in here. We've got a stack containing a local variable I, and we've got our console. Now remember what I said earlier when we were talking about these. I said that continue will basically stop with the current iteration where we're at, and then start running the next iteration of the loop. So it won't finish anything else that's within that particular iteration inside the loop. Okay? So running through this, first thing we're going to do is we're going to initialize I to 0. So let's just say there's a 0 over here. All right, then we come down here and we say, is 0 less than 5? Well, it is. So we're going to come in here and we're going to increment 0 right away. So this time around, I've put my index variable in a different, I'm controlling it differently, just to show them something different. All right, so I'm going to now increment that 0 to a 1. So we get a 1 in here. Now we come down here to our if statement. If I is equal to 3, well, 1 is not equal to 3, so we're going to come down and write out I equals 1, because that's what's being stored. So we hit the end. So again, we will draw our loop out. This time I'm doing very big lines. We're changing everything up for the excitement factor. So now we're going to reevaluate. So at this point, is 1 less than 5? So the first time was 0 less than 5. True. It's good for them to see different test numbers too. Is 1 less than 5? And it is true. So we'll come down here, and what are we going to do? We're going to increment 1 to a value of 2. So we increment it by 1. And then we come down here and we say, if 2 is equal to 3, well, it's not, so we simply skip over that, and we come down here and we write out I is equal to, and the current contents is 2. So we jump back up here to our test, where we're going to say, is 2 less than 5? Answer, true. So we come down here, and what do? We increment I. So 2 becomes a 3. Okay. Then we fall down here and we say, if 3 equals 3, it does. So that means we fall into here. Continue. Well, going by what I said with continue, we simply stop this iteration of the loop and we start the next one. So we jump back up here and we say, all right, fine. Is 3 less than 5? Well, that's true. Notice we never wrote 3 out, did we? We skipped that part of the code. So now since it's true, we fall down inside. So we're right here with the increment. And watch this. Well, there goes 3. Wave bye-bye to it. It now becomes a 4. So it never got printed out. So that's a 4. We come down here on the if line. If 4 is equal to 3, it's not. So we skip over. We're down here on the right line. So now we're going to write out I equals 4. Okay, I can already see where I might need a little bit more room. Well, let's just keep going. All right, so I equals 4. And then we fall down. We jump back up. And then we are now back up here. So is 4 less than 5? Answer, true. So we're going to fall down inside. And what are we going to do? We're going to increment I. I becomes a value of 5. Next is the if line. If 5 is equal to 3, well, no, it's not, so we skip over. So down here on the right line, we're going to write out I equals 5. Then we skip all the way back up to the top, right here again, because that was the end of the loop. Is 5 less than 5? What do we get? False. So what do? When it's false, we continue execution. Yep, I did need a little bit of space. So what gets written out? Finished. And then execution continues outside the loop if there were other lines to be executed. So utilizing continue, we can simply say, all right, we've executed enough code that we need to right now. Let's skip the rest of the code in this iteration and jump back up and continue. What was the code that we skipped? In this particular case, it was the right line. And this is being reflected on the console, the fact that we never printed out the 3. Logan, let's go ahead and code this one up real quick.
Okay. So let's jump back into Visual Studio, where I will wipe out the current example. Everything except the finished. So let's code this out. Let's begin again by declaring I and initializing it this time to 0. Now we can begin our while loop. So we can do while, and the condition will be I is less than 5. Then we can block in the while loop. Now the first thing we want to do is to increment I. So we'll do that, and now we'll do our check to see if I is equal to 3. If I is indeed equal to 3, let me go ahead and block in the if statement. If it's equal to 3, then we want to continue. Otherwise, we want to write out the value of I. So we could write out I...
Or console.writeLine.
Oh yeah, whoops. Console dot...
There we go.
WriteLine, trying to jump ahead and do less stuff, and that won't work.
You're trying to write the way I'm writing on the whiteboard. Sweet.
I'm trying to... Exactly. So we want to write out I is equal to, and then append to that I, and that should take care of the main loop. We still have our finished line outside of the loop, so we should be able to build. Everything looks good.
And let's go ahead and run it. Code's exactly the same, and here we go, ladies and gentlemen. We have 1, 2, 4, 5 finished. 3 has been skipped. 1, 2, 4, 5 finished. 1, 2, 4, 5 finished. That is continue. Very handy stuff. All right, the next one I want to take a look at is going to be goto. And for this one, Logan, we need another sheet of paper. So we'll jump in here and simply hide this one. And goto allows us to jump out of a loop and go to, well, actually, you could
it allows
keep
us to jump in general.
It just allows us to jump in general. It allows us to jump to a labeled portion in our code.
Right, and if that label happened to be outside of our loop, that would, of course, end the loop because we're no longer inside of it.
Exactly. So let's go ahead and do an int I. Let's go back to the regular way now, just changing things around to keep it exciting. Yeah. So while I is less than 5, we're going to come in here and say if I is equal to 3, go to, and we'll just call it jump out. That is the label that we're going to be creating in a minute. It doesn't exist quite yet. Otherwise, we're going to, I'm sorry to write out console.WriteLine and like I'm coding or something now. Otherwise, we're going to write out I is equal to plus I. Okay? And we need to make sure that we increment I so that we don't create an infinite loop. So I'll just do it right here. So I plus plus. So after it writes it out, we'll do that. We'll do this. And then let's do something else interesting here. Let's go ahead and write finished. And then let's come down here and define jump out. So there is our label, colon. And then we can print out jumped here.
Or it could just as in like end of program. But yeah, that's fine. Just put some text to indicate that we reached the label.
Yeah. So, are we ever going to print out finished? Let's take a look. We shall start out by on the stack declaring the local variable I. Okay, so there's I. Here's our console. What goodness is going to be printed out on the console? Execution begins. We come down here with the initialization of I. So I gets the value 1. We then come down to the while statement where we start off with a check. We evaluate is 1. I'm just going to do it up under here. Is 1 less than 5? Answer, true. All right, since it's true, we go down to the code. We come down to the if statement. Is 1 equal to 3? No. So we're going to write out I equals 1 because that's what's being stored in there. And then as a post operation, we are going to increment I to a value of 2. Okay, now we have hit the end of the while statement, which means we come all the way back up to here and we evaluate again. This time is 2 less than 5. Answer is true. We fall down into the code, so we're down into here. If 2 is equal to 3, well, it's not so. We're going to skip over and we're going to write out I equals, and the contents of I is 2. And then what are we going to do with I? We are going to post increment it by a value of 1. So 2 now becomes a 3. I feel like I'm auctioning something off. And then the next thing we're going to do is come back up here to the top once again, and we're going to take I, and we're going to compare it to 5, and that is going to evaluate with a 3 being less than 5 to true to the man in the corner. All right. Since it is true, we're going to fall down inside the while loop, and we're going to do the if. And with the if, we're going to say, is 3 equal to 3? Answer, yes. Since the answer is yes, we are going to do what is inside our if statement right here, which is go to jump out. Well, I don't know why. Well, you could do that because that's where the next line actually executes. But jump out. So now we're going to continue our execution. So what happens? Jump here gets printed. Okay. So that means we skipped out. So we did 1, we did 2, we never wrote 3 or 4, and we never wrote finish. So we should see 1, 2, and jumped here. Logan, take it away.
All right. Back to Visual Studio, where I will once again wipe the current example. Only this time I think I'm going to leave the initialization, only changing it back to 1.
Okay.
Now we can begin on the while loop, which is while I is less than 5. We will now block in the while loop, so that inside of the while loop we can begin with a check. Say if I is equal to 3, and I'll block in the if statement, jump inside the if statement. Now if I is equal to 3, we want to go to, and then I'll give it the label jump out. Alright, so below the if statement, if that was in fact not 3, let's do a right line. And a right line where we can write out I is equal to plus I.
And do plus plus after the I.
Okay, we'll do our incrementing right on this line as a post operation.
Okay.
All right, good. Now
let's jump down up underneath the finished line.
So we'll jump down here below finish.
And let's go and define the label.
So jump out occurs here, where I will steal this line and paste it at the label. So I could say
jumped here.
Jumped here.
All right, so you look at the code. It's exactly what I've got over there. Let's build. Everything builds well. Let's run. 1, 2, jumped here. 1, 2, jumped here. All right, let's come back over here. 1, 2, jumped here. Followed the trace. Perfect. That is how the goto works. Now, you have to be careful with goto. I'll be honest with you. Logan, I'm not a fan of using goto at all. If you're not careful with it, you can end up creating what has been termed as spaghetti code. It can be very difficult for someone to come in behind you and try to maintain your code because now you got all these crazy go-tos that happen because of certain conditions that came up in your code, and that just can really become a nightmare to follow.
Right, it starts to break the modularity of procedural programming, because if you start to throw goto everywhere, then the fact that everything has been defined as convenient modules starts to make less and less sense. It breaks the structure that you're trying to work towards.
That's right. So, to be honest with you, I personally don't advise using it, but that's just my own personal thoughts.
We're just showing it here because it does, in fact, manipulate the way a loop works. If you use a goto to jump out of a loop, that's it. You're done with the loop.
That is exactly right. All right, so the last one is not anything I really need to draw out. Logan, you can just create it. We've all seen return. We've seen return half a dozen times. As a matter of fact, let's go ahead and bring this back up. Okay, well, that's fun. So we've looked at, let's go ahead and just bring our focus back down here. We've looked at break, we've looked at continue, we've looked at goto, and return is simply return from a method. Let's just create something, anything, back over there inside of Visual Studio.
All right, let me think for a second.
Let's go over there and make some method that we're going to call.
So let's make a method that has a loop in it. So we could do something like static void. I was going to say do, but that's the name of an actual loop. So
call it do stuff.
Run.
Or it doesn't matter. Whatever.
Run loop. So inside of this, we could come up with whatever kind of loop we want.
Let's just cut the loop from above.
You could steal this loop. They'll all strip the goto stuff out of it after I.
Yeah, well, just replace goto with.
I see. Yeah, we can just replace it with return.
Yep.
So we could steal this loop. We could go into this goto jump out and replace that with return.
Okay.
And so from that,
now let's just take out the whole jump out and the jumped here lines. Okay.
And then all we need to do now is a call to run loop.
You got it.
So what should happen here, we call run loop, we start our loop, we start looping, we get through 1, we get through 2, we hit 3, we hit a return. Return is going to completely return us out of run loop, and that is by nature going to terminate the loop, much like it would in a goto. Because we're leaving the whole method, the loop is now irrelevant, we're out of the loop, and then we continue running after run loop.
That's right. So we're going to see basically I equals 1, I equals 2, and then finish. Let's go ahead and run it. I equals 1, I equals 2, finished. Okay? So that's just a return. The bottom line is return is simply ending our method call. Inside the method's execution, we're going to return back to the caller in the story. So that's it. That is a look at, let me go ahead and just jump back over here to the whiteboard. That is a look at break, continue, go to, and return. 4 different ways of manipulating a default loops operation. Anything you want to add to this, Logan?
Just to point out that break and continue operate specifically on the loop that they're contained within, whereas go to and return, they happen to terminate the loop, but that's just by nature of the way that they work.
Right.
The reason I bring that up is if you ever get into a condition where you have loops within loops, or other interesting situations like that, break and continue aren't going to necessarily jump completely out of that entire nested group of loops. It's only going to work on the specific one.
That's right.
Whereas in the case of go to and return, you could jump out of multiple loops because they're going to just, you could end that entire method or go to a different label.
Exactly. And I'm glad Logan mentioned that. You can, of course, nest loops the exact same way you can nest if statements. So we can have a loop within a loop. If we wanted to, real quick, we can just make something up. Freestyling here, but just to throw this in because there's no reason for us later on to have an advanced section. I'm going to come over here and add another page. What were you going to say, Logan?
Could do something like have 2 variables, x and y, so you kind of do a 2D coordinate mock-up. I'm trying to remember, we might have done something like that in Hyperion.
Yeah, very much. Well, walking through the, well, I'm just going to do int.
So now this is a bonus section 3, advanced loops.
Int x equals 1. Int y equals 1. And then let's come down here and say, which way do we want to do this? For loops, while loops.
Could almost do it for loops, and then I'll have to initialize outside.
So we can say for, and we've already initialized, so we can do this. Then we can say while x is less than 3. And then we can simply say x plus plus. And then we'll go ahead and start our opening bracket. And now inside of here, we can go ahead and say for. Now, in this particular case, I would want to say y equals 1. Because what would happen otherwise, well, actually, let me just show what would happen otherwise, because this will be really cool. So let me just do...
So if you're using while loops, or if you're using this case and not running an initializer.
Well, actually, that's going to cause a problem, too. Watch this. For, and if I don't initialize this, and I say, well, y is less than... Do you see what the problem would be already?
You'll run it once, but then after that, it rests at its final value.
That's right. So we can run it once like this, and we can come back here and change it so they can see it. But we'll trace it out both ways so they can see it. So while y is less than...
No, do 3 and 3.
Do 3 and 3? All right, that'll work. And then y plus plus. Okay? And then inside here, we'll write out y equals, and then we'll append y to it. And then we'll end this off. And then I'm trying to think. We could go ahead.
Do like
right here maybe.
Just write out in parentheses x and y. Just say chord x by y.
No, I want to keep it real simple for starters.
I got you.
So what we could do is this. We could do a right here. And then with this right, we can go ahead and say x equals, and then of course plus x. And then down here, do another right with nothing on it. So we'll just say emptiness.
Just so you get a separating blank line.
You got it. And then we can close the whole thing off. Alrighty. What does it do? So we're going to come through here, and we've got 2 local variables over here on the stack. So, you know, I was thinking if we cut that and hang on. I'm just looking for a clean. I should have wrote this a little bit more over to the left, but that's all right. I'll come over here. Forget it. So if I come over here and I create two local variables on the stack, so we've got X and we've got Y. X is initialized to a value of 1. Y is initialized to a value of 1. Now, the rest of this space is going to be used as our console. So, execution happened. We're now down to the 4. At the 4, our initializer was left blank. We'll come over here. X is less than 3. So, is X less than 3? So, let me find where I want to write this. So, X, which is what? Which is 1. So, is 1 less than 3? Answer true. So, do the loop. We come in here. The first thing we're going to do is we're going to write out X equals and then 1. Then we come over here and we're going to start another loop. So again, we're not going to do anything with initialization here because it's been left blank. So is Y, which is containing a value of 1, is it less than 3? The answer is yes. So we fall down into its loop and we're going to write out right up underneath this Y equals 1 because that's its current content. We're now at the end of the loop right here. So we're going to come back up. And in doing this, ladies and gentlemen, I hope you don't mind, but I'm going to switch colors here because I don't want to mess up. We're just going to have to switch colors in the console area. You'll see what I mean. But this will help in drawing stuff out here. So we're here at the end now. So we're simply going to come back up. And we're going to increment what is in Y. So what is in Y goes from a 1 to a value of 2. Okay? And now we do what? Remember the way the for loop works. We come back over here. So is 2 less than 3? The answer is yes. So we come down inside and we write out Y equals 2. Then we've hit the end. We come back up and we increment Y from a 2 to a 3. And then we come over here to the test. And is 3 less than 3? No. So since it's not, what do? We simply skip. So we come down here. We're going to write out nothingness, which means that this area is just going to be blank right here. Now what do? Well, we're at the end of our first for loop. So we're going to come all the way back up here and increment X. And so X now goes from a 1 to a 2. And then we're going to check, is 2 less than 3? So 2 less than 3, well, we'll just use this old one. The answer is true. So we fall down inside where we're going to write out X equals, and its current content is 2. Then we come down here to the for loop where there is no initialization. And so we come right over here to our evaluation of is Y. Well, what is in Y? Check it out. Y is still a 3 because it was initialized outside, okay? So, and then it grew because of this loop the first time through. So because of that, well, there's no reason to do the loop because this evaluates to false. So we come down here and we write another space out like such. Then we're at the end of the X for loop again, the outer loop. So we come right back up here again to the top. What are we going to do? We're now going to increment the contents of X by 1. So 2 becomes 3. And then is 3 less than 3? So 3 less than 3. Answer, it's false. No, it's not. So now we'll come out here and that's it. So we should see X equals 1, Y equals 1, Y equals 2, a space. X now equals 2, but nothing with Y. So Logan, let's code this example up real quick.
Okay. And what I'm going to do is I'm going to put it inside of this run loop that we already had set up, because I do want to end this off with the showing the return versus the break.
Okay.
So let me wipe all of this out. And this time we write it as our nested for loop.
Go ahead and change that int I to an int x and y.
So I have an int x. I'll copy and paste that so I quickly get an int y. And then I can begin with our for loop. And the example you had the initializer empty. Then we moved directly onto the condition and checking to see if x was less than 3. And then we incremented x by 1. So that made our outer loop. Then we started on, let's see, what was the next one? Did we have a right line?
Yeah, go ahead and do a right line for what x is.
So we did a console write line so that we can see what the value of x is. So x equals plus x. Now we can begin our inner loop with for, and then I'll have a blank initializer. So I'll just put a terminator. So we'll do a check to see if y is less than 3. And then we will increment y as our operation. And inside of here, let me do I'll just copy and paste this write line for x. So we can quickly have a write line for y. So we'll do a console write line y is equal to y, or plus y. And after that, we had...
Now okay, good.
We had a
console write line that's just empty.
And let's see, that takes care of that. Looking, and we've got our finished back outside of the run loop method. So I believe, let's see, if this builds all right, we should be able to run it.
And so x equals 1, y equals 1, y equals 2, space, x equals 2, space, and then finished because Logan still had finished at the very end. So again, so x is 1, y 1, 2, space. So with that, I can just leave this up real quick. And taking a look at it, here we go. X is 1, y is 1, y is 2. We had the space. Then we had, looking back over here, x is 2. Actually, this will make it real convenient right here. So then we had, after the space, we had x is 2, x is 2. Then after that, we had a space. And then if I'd have had finished this last thing, we'd have had finished up underneath here, and it would have looked absolutely identical. So there you go. This is exactly what we were looking for and what we traced. The only thing I want to change here, Logan, real quick.
Actually, I'm going to do this in 2 steps.
Okay.
My initial goal with this was to kind of have a simple coordinate walker. So we walk through all combinations of x and y.
Okay.
But right now, with the way we have our definition set up for the x and y, we run into what I would consider a problem with this. Because once y reaches 2, we stop looping through y.
That's right.
So our y walker is broken in this case.
That's right.
Let me go through 2 ways of fixing it. Let's say for some reason we wanted to keep the definition of x and y outside of our loops. We could still fix it. We could do that by going in right before we do our y for loop and reset y to its initial value of 1.
That's right.
Now if we run it, we see we have even pairs where we have for each, so every time x is 1, we have y being 1 and 2. Every time x is 2, we have y being 1 and 2. So it always runs every time.
Okay.
And we get every combination. Now I think where you were going with that is another way we could rewrite that would be to simply initialize x and y inside of the blocks.
Or x, you could leave it outside and put, well, I mean, there's multiple ways of doing it here. So you could have just put that right there inside your initializer for the for every time.
So we could do int.
Since you already have it initialized outside, declared and uninitialized, you can just leave that there. And just inside, I was picturing just inside here.
Right.
Simply just doing this.
As an initializer?
And this could have stayed empty. If you were leaving these out here, basically.
If you were, but...
so this would have initialized it back to 1 every
sure,
time.
That would
have
what
I was getting at.
That would just move this code I had here, simply moving it into the initializer.
Exactly, that's what I was getting at. So if you run it,
so we get the same result. Now what I was going at before was that if we had done block level, since there's no reason to have x and y local to this method, we don't use x and y.
That's right.
So the way I would probably end up rewriting this would be to initialize
precisely
I equals 1, int y equals 1, and then not initialize them outside. So that way we have... it just looks cleaner because that way we have loop. What is our desired? Or x doesn't exist. Int. I tried to use I instead of x. And then same result.
Now let's wrap this up with just a little bit more fun. Let's kind of knock this home by reminding them of that rooms grid all the way back in Hyperion in Volume 1, where now for writing out, instead of writing this, Logan, let's kill that line out, and down here let's just write out, do some sort of write line that indicates a square bracket with x and y in it.
Okay, so let's do an opening square bracket, then let's concatenate x, then let's concatenate a comma, or did you want to do you want to do block and block?
Yep. Or no, let's do the comma. I like that idea. That's a good idea.
So we can do a comma.
Yeah.
And maybe a space.
Yep, and then y.
Then y. And then we'll add on another, this time a closing square bracket.
Yeah, there you go. That's
now
beautiful.
If we build and run.
Check it out. Now we have a coordinate system.
And
go ahead.
I'm going to take out this final right line because there's no reason to do any kind of separation here.
Right.
So now we have a list of coordinates. As a matter of fact, I don't like that space. I'm going to take that out. So now we have a list of 4 coordinates, 1, 1, 1, 2, 2, 1, 2, 2.
Very good.
So we've just walked through all possible coordinates for a square grid.
There you go. All right, guys, that really has pushed things.
Ooh, one more thing.
Oh, yeah, excellent.
The other thing, what started all of this was wanting to show break versus return in some of these. So let's put in one of those checks back in. Let's check for. I'm thinking for a second. I want to get higher values. So let's do this. Before I even change anything, let's change these checks back to 5. So we should have our range of 1 through 4 like in our previous examples. There we go. We have a lot of coordinates, but we see we get up to 4.
Mm-hmm.
And that means on the inner loop, so the left side being the outer loop, the right side being the inner loop. Looking at that, that should be right. So we see on the inner loop, 1 through 4, 1 through 4 repeating. What would happen if we did our check? Only I'm going to check a lower value. I'm going to do a check for 2. Saying if, as a matter of fact, I'd rather do this above the right line. Let's do a check such that if I is equal to... Whoops.
Yep.
And I don't even want to do I. I want to do y. If y is equal to 2, then I would like to break out. So we'll do a break. So let's see what the result of this would be. So we've got a break in place. So what exactly are we going to break out of? Well, we know we're going to break out of this loop. Are we going to break out of this one? The answer should be no. So we run.
Yeah, that's right.
So we break out of...
Because we never, every time we get to 2, we break out of the inner loop, which then forces the outer loop to increment to the next one. And then we fall down inside. And then, so do you see what I'm saying?
So, okay, I got you. I wasn't thinking of the magnitude that we're doing. Before we were doing 4 increments. This would have... I just got mixed up my value. If I do that, that's more of what I was expecting.
Oh, okay. I see what you're saying.
I was just thrown off by the fact that we only got 4.
Oh, okay.
But yeah, you're exactly right. What's happening is this, what I wanted to point out was this break is only affecting this inner loop.
That's right.
Because you can see on the outer loop, we do in fact reach all values. We go 1 through 4, so this break has no effect on this outer loop.
That's right.
It only affects the inner loop, so we only reach 2 each time.
That's right. Yeah, if you really want to mess it up.
So here's another thing that I was planning on doing. How about I do a write line to indicate what's going on? What if I did a console write line where I just said break to indicate what was happening as we're running? So 1, 2, break, 1, 2, break, 3, break, 4, break.
So your objective here is just to demonstrate that if you have a loop inside a loop and you break on your inner loop, that's not jumping out of all loops. It's just jumping out of the particular loop that break resides in.
Exactly. So now let's contrast that with return. What if instead of breaking, I did a return, and then just to indicate what we're doing here, actually write out return. What would this do?
Difference.
1, 1, 2, return.
That's right.
So a return, because return means return from this entire method, that doesn't matter how deep we're in any kind of loop. We're going to return from the entire method, stop both loops, and continue outside of that method.
Exactly. Beautiful. All right, guys. Well, wow, I would say we went above and beyond, don't you think?
Well, yeah, I like showing the differences between the two.
Oh, no, I do too, yeah.
That break and continue are specific. I mean, I could write in continue, but I'll leave that for whoever's watching to put in.
Gotcha.
Just replace the return and with continue and see what that does.
All right, guys. Well, that is going to bring this lesson to a close. The primary objective of it was to basically set out and show you break, continue, go to, and return, how these guys will affect a functioning loop, and we have looked at all of them. And then we went ahead and took it a step further, and we did loops within loops, just so that we got that in.
Right, just because I wanted to show the difference of the behavior of break and continue versus the behavior of go to and return. And
we wanted to show embedded loops, too.
But yeah, we needed embedded loops so we could get deep enough into a loop scenario to show the difference.
Precisely. So, guys, with that, that's going to wrap up this section, the whole section of videos. Next video is going to be a knowledge review just to test your skills, prepare for some little challenges, and then that'll have all of the loop stuff brought to a complete close for now. We're going to be covering the for each loop, like I said earlier, just a little bit later on in the course. And with this, we can now start adding looping scenarios into our applications. So with that, that wraps it up. Thanks a lot.